I guess now it's working. Okay, hi, hello, good evening, everyone. Good evening. Now working everything. Everything sorted, right? Yes or no? Everything sorted? All good? Yes, we are doing from starting. Hello, good evening, Ritik. Good evening, Akash. Good evening, everyone. Good evening. So we'll be starting the session right now, and this session is all about circles. We have already done areas related to circles, and now we'll be doing circles. What is the main logic behind doing circles now? And after circles, we'll be doing surface area and volumes. Okay. Now, what is a circle? A circle is a locus of point which moves in such a way that it is at the constant distance from a fixed point in the plane. What do you mean by this? Let's see. What do you mean by this? Let's see. See, if this is a circle, right? This is a circle. Okay. No. Circle should look like a circle. Okay. So, if this is the center, tell me all these points which are on the circumference, they will be at a distance of r from the center, yes or no? Tell me. Tell me yes or no, bacho. Tell me. Okay. If you connect this to this, if you connect, this is radius r. If you connect this point to this point, this is also r. Connect this to this is r. Connect this to this is r. That means every point which is connected to the center is at a distance of r. That is radius of the circle. So we'll say, what is a circle? Circle is a locus. Now, what is a locus? Locus is a predefined path. Locus is what? What do you mean by locus? What is a locus? Locus is path, the route, the way at which the points are moving. So these all points form a circle which are at an equal distance from the center. So that's the locus of a circle. That's the locus of a circle. You can see this. A circle is the locus of a point which moves in such a way that it is always at the constant distance from a fixed point in the plane. Yes or no? Yes, sir? Can we move forward? Sorted? Yes, sir. Can we move forward? Sorted? Now see, what is circumference? Obviously, it is 2 pi r. I'm not going to repeat it again and again. Next thing. What is a chord of a circle? Tell me. What is chord of a circle? Anyone? If this is a circle, this is a circle, right? This is a chord. This inside one, this will be a chord of the circle, right? What is diameter? This one, the largest chord. This is diameter. Diameter, you can call it as the largest chord. Keep on copying, right? I won't say again and again. Keep on copying these simple steps, simple concepts. What is arc of a circle? What is arc of a circle? If you draw a circle like this, if you draw a circle like this, let's see. If you draw a circle like this will be called as an arc of a circle. This will be called as an arc. Obviously, this is small. This is smaller one. So this is a minor arc. This is a minor arc. The larger one, the bigger one, the bigger one is major arc. The bigger one, you can see this thing very clearly. The bigger one is major arc. This is major arc. Everyone got this point? This is major arc. Sorted. Can I move forward? Yes or no? Okay, let's move. Now, see, you can call it as, say, this. If this is AB, this is point A, this is point B. Okay. If this is point AB, you'll write AB arc. This is called as AB arc or arc AB. AB arc will be called as AB arc or arc AB. Sorted? Sorted. Now see, sector of a circle. What is sector of a circle? If you connect this arc to the center, if you connect this thing to this thing, if you connect this point to this point, this whole red part will be called as, this will be called as what? This complete thing will be called as what? Sector. Sector of circle. Right? Sector is a part of the circle. We have done it in areas related to circles also, right? Now, what is segment of a circle? What is segment of a circle? If you draw a circle like this, see, if you're drawing a circle like this, let's say this is a circle, okay? If a line is drawn like this, right? This part is called as segment. This is called as minor segment. This is called as minor segment, okay? The larger one is called as major segment. Major segment. Now, tell me one thing. The minor arc will produce minor segment, yes or no? Minor arc will produce minor segment. Major arc will produce major segment, yes or no? Sorted. Got it, got it, got it. Yes or no, sir? Sorted. Yes or no, sir? A minor arc will produce a minor segment. A major arc will produce a major segment. Okay. Intersection of a circle and a line. It could be in three ways. Intersection of a circle and a line, it could be done in three ways. So we'll explain what are those three ways. See, if this is a circle, this is a circle. Okay, let's say three circles we'll draw. Let's say three circles I'm going to draw. See, the circle, this is also a circle, this is also a circle, right? A line is going, see, a line can either intersect or touch a circle, right? If the line is going like this, it is called as secant. It is called as secant. If a line is going and touching the circle, it is called as a tangent. It is called a tangent. If a line is going but it's only inside the circle, it is called as chord of the circle. It is called. Draw all these three diagrams. Draw all these three diagrams and we'll move forward. Very soon we are going to launch a new uh, system on YouTube. All these lectures which I am doing right now and the lecture which is at 5 p.m. daily, you must be knowing that. Those live classes will be only for members, okay? From after Diwali, this new feature will be enabled. Only members mode will be activated. It is active right now also, but inside that you will find courses from 22nd or 23rd of October, right? Yes, 3-4 days after we'll be having only members mode, so that nuisance people, nuisance guys, they will be uh, they have to stay back, because that will be only after paying for the members mode, okay? After 4-5 days, these all live classes which I am taking right now, and the classes which are live at 5 p.m. daily, or in the morning 11 a.m. right now till the Diwali holidays are going on, those classes will only be available to member students, but natural after paying a minimum amount of fees, right? So that will be the scene for we'll be having, okay, right? I actually want that nonsense people should be away from my live class. I want this. Now you think who is sensible and who is actually a nonsense for these classes? You guys know better, okay? Okay, next. Intersection of a circle and a line, okay? Enough of serving free lunch to so many idiots. In clear language, in clear words, I must say, enough of serving good lunch and dinner for so many idiots. Okay, now it's time to get the level of Matholics where actually we deserve to be. Yes, so we'll be having. Don't worry, we have hundreds of members already ready. Don't worry, you just focus on your studies. Uh, just focus on your studies, dear. Okay, especially for 11th class and 12th. For class 11th and 12th, the members section is very crowded. Okay, we'll be starting from Day after 2. Day after, yes, it will be under rupees 200. It will be under rupees 200, not so high. It will be under rupees 200. Okay. Only on YouTube. We won't direct you to any application. It will be on YouTube only, and at least 20 to 24 lectures every month will be there. 20 to 24 lectures every month will be there. Okay. Now, intersection of a circle and a line. Now see. In fact, in offline classes also I'll be talking to the member students. That will be a benefit. Can we move forward? Okay. Intersection of a circle and a line. It can be done in 3 ways. Okay. It can be done in 3 ways. Now, minor segment and major segment I have told you already. Okay. Now, what is second tangent we have done? Tangent as a limiting case of a secant. See, can you tell me at a point how many tangents are possible? At a point on the circle, how many tangents are possible? Are possible. Okay. Question. The circle. If this is a circle and this is a point. See, this is a circle. Okay. This circle and this is a point. How many tangents are possible? Let me please clear me. At a point on the circle, how many tangents are possible? Anyone in the comments fast? At a point on the circle, how many tangents are possible? Anyone? No. At one point, only one tangent is possible. If it is diverted by a little also, say the tangent is passing through this direction, so it will go like this. Okay. So the point will be changed. Yes or no? So at a given point, only one tangent is possible for a given circle. Right? Up and down. Now see, only one tangent. Answer is, this is 1 mark question. Answer is only one tangent. Okay. Okay. Next question is, how many tangents are possible for a circle? Come on, tell me. How many tangents are possible for a circle? Anyone in the comments? I'll be happy to see. How many tangents are possible for a circle? एक circle के लिए how many tangents are possible? This is T. First thing. How many tangents are possible for a circle? Anyone in the comments? I am waiting for your answers. How many tangents are possible for a circle? For one circle, how many tangents can you draw? Come on, anyone. Let's see. You talk about conceptual knowledges, no? Yes, I am here to talk about conceptual knowledges. Anyone in the comments? Anyone? Conceptual knowledges. Yes, sir. How many tangents are possible? For a given circle? Many tangents. Akash, very good. See, this kid is actually trying to think. What I say in my lectures, मैं सोचना सिखाता हूँ. I don't make you to learn or memorize or rattafication. You know what is rattafication? Don't be a rattu. Would mean don't just keep on grabbing knowledge and okay. No, think. सोचो. मैं सोचना सिखाता हूँ would mean I make you how to think. I make you learn. मैं सोचना सिखाता हूँ. What does this mean? I make you learn how to think. सोचो. If there is a circle, see if there is a circle. Okay, there is a circle. So how many? This is a tangent. Yes, sir. Is this a tangent? Yes, sir. Is this a tangent? It is touching and going. Is it a tangent? Yes, sir. It is touching and going. Is it a tangent? It is touching and going. Yes or no? Right. That how many points are there on the circle? At every point there is a tangent. This point there is a tangent. So at every point there is a tangent, so there are infinite points, so there will be infinite tangents. Yes or no? Come on, tell me in the comments. There will be infinite tangents. Yes or no? Yes or no? Answer is infinite. See, doing questions, people will say you, they'll crack the paper, they'll leak the paper, they'll give you questions. Out of those 50 questions, 20, 30 will arrive. The data will be matched. You will say, oh my God, paper is leaked. And in class 11th, when you will be forced to think, then it will be a true failure for all of you. If you're going just behind, sir, please leak the paper. Sir, please tell the questions what will be important for exam. Every damn concept is important for exams. What do you think? Every concept is important. Okay. I actually laugh when students ask me in the class that, sir, please tell us important question. What is important? I am important. You are important. Your pen is important. Your exam paper is important. Your exam answer sheet is important. Your teachers are important. Most importantly, your friends are important, whom you actually look for. Oh, थोड़ा दिखा दे भाई, थोड़ा दिखा दे, दिखा ना. Don't do these type of practices in exams. CBSE board especially, they are having CCTV coverage all over. They can put you out of the examination hall also. Okay, so just focus on your exam, on your answer sheet, on your question paper, on your teacher, on yourself first. Okay, no one else is going to help you. Okay, can I move forward? Yes or no? Sorted. So let's see. Next, properties of a tangent. Properties of a tangent. Properties of a tangent. First property is theorem. Theorem number one is the tangent at any point of a circle, tangent at any point of a circle and the radius through the point are perpendicular to each other. That means what they are saying, if this is a circle, okay, this is a tangent going like this, okay. If from center you join the point of contact, it's going to be perpendicular. If AB is a tangent, what is given, we'll prove this. Exam also you can get this question as it is. Given, what is given? That tangent is there. AB is a tangent. AB is a what? Just wait, huh? I'm seeing some breakages there. No. Okay. AB is a tangent. Okay, sir. What do you guys have to prove? To prove, required to prove. Required to prove. Obviously, this OP is radius. This is radius. Yes or no? R. I can write it as R. Required to prove that OP is perpendicular to AB. This we have to prove. OP is perpendicular to AB. Will this by contradiction method also we can do. Okay, let's see. Let's see. Just take a point. Just take a point Q. Just take a point. Take a point Q outside the circle and join OQ. Join OQ. Now, can you see the see? Can you see OR is less than OQ? OP is also less than OQ. Yes or no? Tell me. This method is called as just method of vision or what you can solve it. But just you have to write 2-3 points. You just have to write 2-3 points. Yes, I think it must be easier for every one of you, but some of you would be thinking it's difficult. We are taking circles from scratch, from the basics. Okay, now OP is perpendicular to AB. Proof. How to prove? See, how to prove? Since OQ, this point is R. Since we can say OR is less than OQ. Tell me, yes or no? But OR is actually equals to what? OP. It implies we'll write OP is less than OQ. We can say OP is the smallest distance. It implies OP is the smallest distance smallest distance between O and AB. O and AB. And shortest distance will be what? Perpendicular. You know this point? Shortest distance OP will be perpendicular to AB. That's it. Smallest or shortest. Okay. You can write it more precisely, shortest. Copy this. Copy this. See, these are so easy questions that they can, if they come now, you'll see, you'll say, what to write? I don't know what to write actually. I don't know what to write actually. Clear? Yes or no? You'll just say like this, I don't actually know what to write. Okay. Copy, copy. I'm giving you 1 minute. Copy. ASAP. Huh? Don't waste time. We said what OR is actually less than OQ. This line is visible that this is less than this. But OR is equals to OP. So like OP is less than OQ. So we see OP is the shortest distance. OQ is larger. This one will be larger. Everyone will be larger. But OP is the shortest distance. So OP will be perpendicular to AB. ये prove करना था. That was about to prove, right? To prove OP perpendicular to AB. Copy this. Sorted, done. Okay, let's move forward. That was theorem number 1, that if we see a circle, right? If we see a circle, okay, this is a tangent. If we draw the center, we connect to the point of contact. This is perpendicular. This is a theorem. You must remember this. Okay, okay. So these points to be remembered: a pair of tangents drawn at 2 points of a circle are either parallel or they intersect each other outside the circle. Yes or no? Yes or no? The PDF is clearly visible or no? Yes, it's clearly visible. Yes, yes, I can see. If I can see, you can also see in your sets. Okay. If this is a circle, point number 1, let me clear it. If this is a circle, okay. A pair of tangents drawn at 2 points on a circle are either parallel. They will be either, see, if this is going like this, another tangent is going like this. Can you say this is parallel to this? Yes, sir. This tangent is parallel to this. Okay, yes, sir. Or if this is a circle, one tangent is going like this. It is touching. Okay. One tangent is going like this. Okay. So another tangent, if it is going like this, they will intersect, yes or no, at a point P. These point of contacts are A and B. So this tangent and this tangent will intersect. Either they'll be parallel or they'll be intersecting, yes or no? Either they'll be parallel or they'll be intersecting, yes or no? Tell me. Yes, sir. Now see what the point is. Point number two. Point number two, what does it say? If two tangents drawn to a circle are parallel, then the line segment joining the point of contact is a diameter, yes or no? If this is a circle, tell me, right? If this is a circle, let's say one tangent is going like this, another tangent is going like this. Okay. They are saying the line segment joining. The line segment joining, that means this one, this will be the diameter. Yes, sir, obviously, yes. Why? So this angle is 90 degree. If this angle is 90 degree, we can say this line will pass through the center O. Yes or no? If this angle is also 90 degree, this line will pass through center O. So obviously this is a straight line and this will be nothing but the distance will be diameter. Keep on copying the diagrams and whatever I am saying, right? This will be the diameter of the circle. Yes or no? This will be the diameter of the circle. Okay. Next thing, see, this is point number two. The distance between two parallel tangents to a circle is equal to the diameter of the circle. This is clear. Okay. If this line is parallel, if this is parallel, if these lines are parallel, this distance has to be the diameter. Point number fourth. Point number two and three combined here. Point number fourth, what does it say? We have done this point, this point, this point, now this point. A pair of tangents drawn to a circle at the end point of a diameter are parallel to each other. If this is a circle and this is a diameter and this is the diameter, if you draw one tangent here and other tangent here, one tangent here and other tangent at the point of contact here, this line has to be parallel to this line. Yes or no? This is the diameter. This line is the diameter. If parallel tangents are there, the central line, the line joining, their point of contacts will be diameter. Vice versa is also true. If diametric ends, we draw tangents at the diametric ends. That means this point and this point. We are drawing two tangents. These tangents will be parallel. Yes or no? Yes. Point number four. Sorted? Clear? Can I move forward? Yes. Next thing, C. Point number five. Point number five. A pair of tangents drawn to a circle at the endpoints of a chord other than the diameter will intersect outside the circle. What does it say? If this is a circle, see. If this is a circle, okay. They're saying if this is a chord, right? And you draw tangents at these 2 points. Let's say one tangent is this. So other tangent will come intersecting this tangent at this point. Yes or no? If two tangents are drawn at the endpoints of a chord, they will intersect at the endpoint. They will intersect at the endpoint. Yes or no? These are some basic points, basic overviews which you must know actually to solve problem questions, right? Ha, 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 ha. Okay, that's it. A line drawn through the endpoint of a radius and perpendicular to it is tangent. Okay, there's no need now to prove. Okay, this is good question. This question you must copy. If O to be the center of a circle, there's given a circle, we have been given, what we have been given, see. There's a circle. Okay. There's a circle. Right. O be the center of a circle and tangents drawn to the circle at the points A and B of the circle intersect each other at P. Let's say these are 2 points A and B. Tangents are drawn like this. Tangents are drawn like this and they are intersecting at a point. They are intersecting at a point P. Okay. Now from the center O, if you join these points, and these points. They are saying prove that. Given is what? AP and PA and PB are tangents. PA and PB are tangents. Okay, sir. What is required to prove? What we have to prove? We'll write. What we have to prove? We have to prove angle AOB plus angle APB equal to 180 degree. This we have to prove. Yes, sir. Copy this thing. This we have to prove. Now, what will be the proof? What will be the proof? See, what will be the proof? You tell me one thing, every one of you. We know that OA is perpendicular to AP and OB is perpendicular to PB. Yes or no? That means this is 90 degree and this is 90 degree. Reason. Center joining the point of contact is always perpendicular to tangent. It implies we have to prove what? Angle this plus angle this, that's equals to 180 degree. If you add all these angles, add angle AOB plus angle APB, this angle plus this angle, plus this, that means plus 90 equal to 360 degree. Why? Angle sum property of a quadrilateral. The quadrilateral will have angular sum what? 360 degrees. Yes. So 90, 90, 180, then it will go subtracted, implies angle AOB plus angle APB equals to 360 minus 180, 180 degrees. Hence proved. Copy. Easy. Very easy. You can actually use this concept in any question also, that this and this will be supplementary. Supplementary means their sum is what? 180 degrees. Complementary means their sum is 90 degrees. Supplementary means their sum is 180 degrees. Copy it. If done, then tell me. You can rewind and see. How can I repeat? You can rewind and see 2 minutes, 3 minutes back. Done. Can we move forward? Done. Okay. Okay. Don't worry. Now see, this was corollary means results. Corollary means results. If to okay, the good question. Okay, question is, you must write it down. You must write it down, every one of you. Very good question. See, if two tangents drawn to a circle, if two tangents drawn to a circle from an external point, two tangents are drawn to a circle from an exterior point. Okay, prove that tangents are equal in length. The tangents subtend equal angles at the center. The tangents are equally inclined to the line joining the point and the center of the circle. See, one by one we'll prove. Two tangents are drawn to a circle. If this is a circle, okay, let's draw it here. No, circle should be, okay, this one. This is going good. This is a point P. Tangents are drawn to a circle from an exterior point. This means this is the exterior point P. You're drawing tangents from here like this. One tangent is this and another tangent is this. They are touching this point. Okay. Now they are saying prove that tangents are equal in length. If this is A, this is B. Required to prove, what we have to prove? First point, PA equals to PB. PA is equals to PB. We have to prove. This we have to prove. Okay. How to prove? Prove. Construction you have to do. Construction, what construction you have to do? I'll tell you. Wait. Construction, join, this is center O, join OA, OB and OP. Right. This you have to join. We know that OA is perpendicular to PA and OB is perpendicular to PB. Yes or no? These angles are 90 degrees. Okay. So take these triangles. In triangle, first triangle is APO and triangle BPO. Upper triangle and lower triangle we are taking, right? This angle is 90. Okay. Right angle. So we'll write angle OAP is equals to angle OBP, that is 90 degree. Why? You must write the statement that line joining center to the point of contact is perpendicular to the given tangent. Line joining center to point of contact is perpendicular to the given tangent. Okay. Now this is point of contact. This is point of contact. This is point of contact here. Okay. Now, what we can write in addition, right angle is there. Okay. Can we say OP equals to OP common side? OP equals to OP common side, which is also the hypotenuse for these triangles. Opposite 90 degree. This is hypotenuse. Yes or no? Okay. Common hypotenuse. Okay. And this side is equal to this side. Yes or no? This was the common. But OA is equals to OB. Why? Radius. Radius. So can I say by RHS, this is right angle, this is hypotenuse, this is a side. By RHS, triangles are congruent. By RHS, by RHS congruency, triangle APO is congruent to triangle BPO, right? It implies, very simply we can write everything. They were saying tangents are equal in length, tangents subtend equal angle at the center. We can say everything. See, first point, it implies PA is equals to PB, hence proved by CPCT. Okay, corresponding parts of corresponding triangles are equal. Second point, it implies what? These angles will be equal to this angle, yes or no? That means angle are equally inclined at the center. Tangents are equally inclined at the center. That means what? Angle POA equals to angle POB. Third part, what they are saying, tangents are equally inclined to the line joining the point and the center of the circle. That means subtend equal angles at the center. This was one thing. Last thing, this angle will be equals to this angle. Yes or no? The tangents are equally inclined to the line joining center and exterior point. Yes or no? That means angle APO equals to angle BPO. Hence proved all the 3 points. Copy this. Copy this. We had to prove that length of the tangents is equal. PA equals to PB. How we proved? By proving both these triangles as congruent. Copy this. Probability. Oh, ho, ho. Right now I'm teaching circles. It's better you should learn this. Okay, copy this, copy this, copy this. Tell the difference between secant and tangent. Watch this lecture in the starting. I've already told everyone, right? When the lecture ends, you can see it from the starting. Done? Okay. In continuity to this question, see, that was a theorem. That is a corollary. It's a result. Right. This was a theorem that two tangents drawn to a circle from an exterior point are equal. You can use it directly. Okay. You can use this theorem directly. This is theorem. This is what? Theorem. Theorem means the fact. Okay, you can use. Now, what is corollary? Corollary means its result. Its result is what? If PA and PB are two tangents from a point, say this is PA, the circle, it's PA, it is PB. These are two tangents, okay. These are two tangents, okay. Drawn to a circle with center O touching it at A and B, okay, and B. And we have to prove that OP, this OP is perpendicular to, this OP is perpendicular bisector of AB. Prove that OP is perpendicular bisector of AB. This AB, we have to prove OP bisects AB. OP bisects AB. That means AC equals to, required to prove is what? Required to, in this diagram also I am saying AC equals to BC. AC equals to BC, we have to prove. Right? So if in triangle ACP, this triangle, these small triangles if you take, these small triangles if you take this triangle and this lower one triangle, okay, these two triangles, okay, can you see in the diagram clearly? Now if you use these two triangles to prove, how will you prove it? You'll say, okay, this is equal to this, okay, you know that, and PA goes to PB and PC goes to PC, common, this side is common, and third one, angle ACP, this angle is equals to angle this angle. Why? Or you can use this angle equal to this angle. See, I'll draw the diagram again. See, this is the triangle, circle. This is the circle, and these are the two tangents. Okay, these are the two tangents. They are saying, okay, this is point O. You can join these. This is A. This is B. This is P. Okay, and if you join this line is given as okay. You are asked to prove that this line is joining to this line. So this is O. You have to prove OP is perpendicular bisector of AB. So required to prove is what? AC equals to BC. This point is C. And angle ACP equals to angle BCP equals to 90 degrees. This angle equal to this angle, 90 degree you have to prove. So in first proof, you will write what? Take two triangles. In triangle, first triangle, upper one, ACP. In triangle ACP and triangle ACB. These are ACP and BCP. Sorry. ACP and BCP. These triangles. This triangle only. Upper part. So write what? Tell me what we are going to write. We will write, we know that PA is equals to PB, yes or no? PA is equals to PB. We know that tangents are equal. Tangents are equal. Which tangents? Drawn from, you will write complete. Tangents from same point, tangents drawn from same exterior point to a circle are equal in length. Yes or no? Yes or no? Sort. Now, first thing is ACP equals to, PA equals to PB. Next thing is PC equals to PC. Common. Is it common side, yes or no? So you have written this and this and this and this. If the included angle is equal to this angle, then we can say by SAS criteria triangles are congruent. So this angle is actually equal. We know that tangents are equally inclined. Then APC equals to angle BPC. Reason you can write in bracket. So by SAS congruency, triangle ACP is congruent to triangle BCP. Yes or no? Yes, sir. So can we say it implies, last part can I write it like this? It implies by CPCT, corresponding parts of corresponding triangles are equal. Can we write AC equal to BC? AC equal to BC. Okay. First thing proved. Second thing, I have to prove that this angle is equal to this angle. Also, angle ACP equals to angle BCP. Yes. But sum of these angles is 180 degree. But we know that angle ACP plus angle BCP equal to 180 degrees. Yes, linear pair angles, but these are equal. It implies twice angle ACP equals to 180 degree. You can write it ACP, ACP, BCP, BCP, whatever. It implies angle ACP equals to 90 degree, and that's also equals to, because ACP was equals to BCP, angle BCP. Hence proved. Last you have to write it like this. Hence proved. Yes or no? Sort it. Yes or no? Tell me. Tell me in the comments. Yes or no? So this you have to copy. That's it for today. I am making this lecture end here, but you can copy every part of this lecture, right? This question especially, last point, amazing question, last one. So keep copying. Tomorrow onwards, we'll start doing questions for tangents, right? Questions for tangents are about to come. Example 1, example 2. You'll enjoy the lecture which is going to be held tomorrow. Tomorrow is, I think 18th, right? Okay. So we'll be having Diwali break, I guess, on the day of Diwali, and after Diwali also we'll be having break for 2 days. We'll see, we'll continue classes from 23rd or 24th, whatever will be the date, I'll tell you. Tomorrow there will be class, day after tomorrow there will be class, then we'll let you know the holiday dates, right? So that's it for today. This is up, Captain JP signing off. Copy this and then sign off from this lecture. Bye bye, take care, good night.